Hi, so today I want to go over what a milliradian is and also the formula for range estimation and how it works. So to understand what a milliradian is, we want to kind of go back and really understand what a radian really is. To understand that, here I'm going to draw a circle. And the cool thing about, or the definition of a radian, is that let's say that the radius of the circle is 1. And so 1 radian is actually saying the arc length, the distance here, is going to be the same as the radius. So we could say here, that's theta, and we're going to say this is 1 as well. Now, having said that, we could say that 1 radian is equal to when the arc length equals 1 radius length. Now, that being said, 2 radians is going to be when the arc length is going to be 2 times the radius length, and so 3 radians would mean that the arc length is 3 times the radius length. And so now that we know that, I'm going to erase it. We want to ask ourselves, well, how many radians are there in a circle? Now, knowing that pi is a ratio, some people would think 3.14, blah, 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 blah. It's just a ratio. It's going to be a ratio of circumference of a circle over the diameter of the circle. So when we know that the circumference is 2 pi r, I'm not going to derive that today. When we know that, we could ask ourselves, well, since we know that 1 radian is when the arc length is 1 radius, then when we have this whole thing, well, how many times does this divide by the radius? And that'll give us how many radians are in the circle. So we do 2 pi r, and then we're going to, like I said, we're going to find out how many radians fit in a circle. So we're going to divide this by r, and lo and behold, the r's cancel out, and we're going to find that there are 2 pi radians in 1 circle. Great. Okay, so now that we know that there's about 6.28 radians in this 1 circle, we can move on. So actually, I'll keep that there. And now that we know that, I want to convert radians into degrees. So if I want to find out how many degrees 1 radian is, what I know is I could do, let's see, 1 radian it's proportional, so it's 1 radian, and if we know that 2 pi radians is, so this angular measurement, 2 pi radians, is 360 degrees. And when I get my calculator, so all we're going to do is that the radians cancel out, and we're going to be left with, it's going to be 57 something. Give me a second, I want to give you the exact number, or a really good approximation of it. It's going to be 57.2958 degrees. So each radian is going to be 57.2958 degrees. Cool. Okay, so then now we know that what 1 radian is, if we use the definition of a milliradian, milli means 1/1000th of something, all we have to do is divide this by 1000 to find out what 1 milliradian is. So 1 milliradian is going to be, so 57.2958 divided by 1000, all you're going to do is carry move the decimals a little bit. We're going to get that 1 milliradian is 0.057296 degrees roughly. Okay, cool. So remember that. I'm going to erase all this now. Actually, I'll keep the bottom part so you guys don't have to memorize it right now. Then when we look at what 1 milliradian is in arc length, we're going to use a small angle approximation, and it comes out really, really close. You could use Taylor series to get the exact answer, but let's say, and this is not to be scaled, let's say this is 0.057296 degrees, and let's say that this is our radius is going to be 1 meter. Then we could find out if we call this height, what the height is going to be. Now the height, we could use sine 0.05729 blah 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 equals height over 1 meter, right? So then when we plug this in our calculators, we're going to find that height is going to be 0.99999 blah. It's going to be 1 meter. Or, sorry, in this case, it's going to be like 0.009999. Let me put that in the calculator real quick. Yep, so it's going to be 0.00999, or if I could go back, roughly 0.001 meters. So that means if this is 1 meter, if that's 1 milliradian, that's going to be 0.001 meter. Now, taking that, and if we say that this is no longer 1 meter, and say this is 1,000 meters, then same thing, it's going to be, height is going to be 1 meter. Now you can plug that in the calculator, and you can find that that's going to be 1 meter, which is very cool. You can also see that this arc length is also just r times radians, and if radians is 1,000, then the arc length is going to be basically the radius. So if it was 1, then it's going to be 1/1000th of it. If the radius is 1,000, then we're going to do 1,000 times 1/1000th radian, so 0.001 radian. Then we're going to get our height to be 1. So this one's going to be like 0.9999 blah, but using small angle approximation, we say that the arc length is equal to the height here. Cool, right? Alright, so now we're going somewhere. Now that we know this idea, we can move on, and we could say that, well, how do we find how many mils something covers? Then what we're going to do is that, let's say we have a scope, and it could be first focal plane, but in a nutshell, if this is going to be our objective lens, here's our turrets, and this is our eyepiece, and let's say our reticle is going to be in here. It's basically just saying that when the image is projected, this spacing in between the mils here, so to put it into 2D, and if this is a mil dot, so here to here is going to be 1 mil, here to here is going to be 1 mil, etc. The spacing in between here is always going to be 0.057296 degrees. Cool, right? So now you've established some constants, and we know that 1 mil out of 1,000 meters is going to be 1 meter, and we know all this. Here comes the cool part. Because everything's proportionate, and now we have constants of 0.05729 degrees, erase this. Let's say we are out somewhere and we see a bad guy, and the bad guy is, you know, pretty big. Let's say he's 2 meters, and we're looking through a scope and we see that it covers 2 mils, just to make things easy. So we see our bad guy and it covers, let's say, 2 mils. Now 2 mils is just going to be 2 times 0.057296 blah 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 degrees. And so to find the range, all we're going to do is sine. So that's going to be, put that in my calculator real quick. I think it's going to be, oh well. 0.11459 equals the height, and this is the range, or our radius is going to be h over r. Now if we know the height in this case, we know that this bad guy is 2 meters. We're going to erase that height. We're going to put 2 meters. We're going to find that when we plug this in our calculator, and I'll do that real quick. I mean, I already know what the answer is going to be, but what we're going to do is we're going to bring the r over here, and we're going to do 2 meters divided by sine 0.114 blah blah blah. We're going to get 1,000. So that means that because we knew the height, we know that the range, when this covers 2 mils, is going to be 1,000 meters. All right. So that was an easy example. Now, let's say that we have, but now I'm going to not give you another example, but dive right into proportionality. So let's say our angle is 4 mils. And I want to go into proportionality. So now the radius, we're going to say, is 1,000. We know for a fact that 1 mil at 1,000 as our radius is always going to be 1. 4 mils, and you can do it in your calculator, is always going to give us 4 meters. So that's our fact. That's a toolbox. And because we know this, let's say that we have 4 mils and a height of, oh yeah, so we bring the bad guy back in. So now, the same 4 mils, meaning if I have a reticle, space that out a little bit better, 3, 4. So that's a distance of 4 mils, and we see the bad guy. Got short feet. Sorry about that. 1, 2, 3, 4. Right. So now it's covering 4 mils, and we know that he is 2 meters. Then what's going to be the distance that he's going to be away? So to do this, what we're going to do is we could use sine. Sure, we could do sine 4 times 0.05 equals 2 over r, and that'll give you the range. Cool, but because we know about proportionality, we know that, I'm going to write this in red, if I can find the red marker. Okay, green will have to do today. Yeah. Alright, so then we could write with proportionality 4 over 1,000 is going to be, let's say, 2 over x. So that's saying 4 given at 4 mils, 1,000. That's going to ask yourself, what if it's 2, and what's our range going to be? Now when we cross multiply, we're going to get 4x equals 2,000, and then x is going to leave us with 500. Cool, right? So if we know that because this is always a constant, 4 meters at 1,000 meters, and 2 meters is our given, and this is going to be our range, when we cross multiply, we get 4x equals 2,000. X is going to give us 500 meters. Cool. All right. So now remember that idea of proportionality. And knowing that rule of proportionality, we could say that at 1 meter, it's kind of, you could think of proportionality as a rise over run, kind of like a triangle. So let's say that this is, let's say 3, I don't know, we could say this is 9, then this angle, when it's constant, the proportionality of rise over run would mean that if I go extend this another 9, so that's going to be give us a total of 18, and this is going to be from 3 here to another 3. We just extended the line. We know that that's going to be 6. This one's going to be 18, and we know for a fact that 3 over 9 is the same thing as 6 over 18, right? So that's called proportionality. We're just extending the triangle a little bit bigger or shortening it sometimes, and we know our proportionality. So 3 over 9 is always going to be 6 over 9. Okay, so using that proportionality, given that at 1,000 meters, it's always going to be 1 meter. It's going to be our range, or our radius, and our height. So when we cross multiply everything, so that's going to be mils. So, I mean, it could be 1 meter. It's going to be the same proportionality. But when we do mils, mil over 1,000 meters. So like I said, 4 mils, or 1 mil at 1,000 meters is going to always give us 1 meter. If it's 4 mils, then on 1,000, that's always going to be giving us 4 meters. When we cross multiply this now, we're going to get range times mil equals height times 1,000, and then our range in meters is going to be height in meters multiplied by 1,000 divided by mils, which gives us our equation for range estimation. So we could use this now, and we could, if we're given the height and we can find out how many mils it covers, we could use this equation to find out our range. Awesome. I hope you guys enjoyed the video. I know it's a little bit long, but I tried my best to make it as short as possible. Thanks for watching.